Good morning, good afternoon, good evening, whatever the case may be. I just love changes. It's perfect because, again, calculus is the study of change, boys and girls. And this is the area under a curve part 2. And here I'm going to show you a couple of examples. Okay, sketch the graph of y equals x to the fourth. For 0 less than or equal to x less than or equal to 1, and then shade the area described by this integral. So let's go ahead and do that. Let me get my nice little arrow tool here. And so we'll have my y-axis, my x-axis, and we're just going to do a quick little sketch. So we're only going from 0 to 1, so x and y. And let's see, when x is 1, y is 1. So this looks very much, just from in this domain, like the curve of y equals x squared. A little bit steeper, but this will do fine for our purposes. And now it says to shade the area described by this integral, the integral from 0 to 1 of x to the fourth dx. So that is going to be, see how straight I can get. It's going to be this pink area in here, right in here. Okay, I'm shading as best I can. All right, that's good enough. All right, use technology to calculate the lower and upper rectangle sums. Now this is going to be our left rectangle and our right rectangle, the way we've been talking about it in class, for n equal subdivisions, where we have 5, 10, 50, 100, and 500 subdivisions. Okay, so since we have to do left and right, I just want to talk about something real quick, because we had just talked mostly about the right-handed rectangles. But if I have left-handed rectangles, my first rectangle is going to be at x sub 0, or the first height, and the second rectangle is going to be have a height calculated using x sub 1. If you think about it, here, let me get a different color, maybe green in here. See, there's my left rectangle. 1, let's just do 5. 2, 3, and you have to work with me and assume that these are all the same size. 4 and 5. So x sub 0, x sub 1, x sub 2, x sub 3, and x sub 4. Okay, and if we use right-handed rectangles, I'll do this with red, I guess, then you go from x sub 1 to all the way to x sub 5. So from here to here are going to give me the heights of my right-handed rectangles, and from here to here are going to give me the heights of my left-handed rectangles. And of course the height of the furthest one for this particular function is going to be 0, since 0 to the fourth power is 0. So how are we going to use technology to calculate the lower and upper sums? I'm going to use Excel. Your calculator is fine as well. So since we might have to start at 0, our first x sub n could be 0. So I am going to start my number here at 0, and then 1. And I'm going to go all the way down to 500, but I want to get everything in here. The first thing I'm going to do is 5 rectangles. Then I'll go straight to 500 rectangles. So if I'm going to have 5 subdivisions, I'm going to have to take this and divide it by 5. So 0 divided by equals, this cell divided by 5. Okay, and then I'll click and drag to get that formula in there. The length is going to be equal to x sub n to the fourth power. If we go back to the drawing here, remember, that's going to be the height, f of x sub n, gives me the height. And my function is x to the fourth power. So I'm going to say, okay, that equals my x sub n, clicking, to the fourth power. And of course 0 to the fourth is 0. And I'll drag that down, and x sub 1 here is 0.2, and 0.2 to the fourth power is 0.0016. So the area of this rectangle is going to be equal to its length multiplied by its width. And if I'm only having 5 rectangles from 0 to 1, the width is going to be 1 divided by 5, or 0.2. Okay, and so I'm going to drag that down. Okay, so now I'm going to drag all of these down until I get down. So I'm going to have to go to, let's see, 1, 2, 3, down to there. And here I have my 5 rectangles. Actually, I have 6. So let's think about the sum using left-handed rectangles. Left and then right. Okay, back to left. Well, that's going to equal the sum from the first 5 rectangles. 1, 2, 3, 4, 5. So that would be this area. So that's going to be D2 to, let's see, D6. Bam. And then for right rectangles, that's going to equal the sum. And since we're up here, we can just highlight it from x sub 1 all the way to x sub 5. And oops, what did I do? I forgot I just messed that up. So let me get rid of that. I equals sum. Then I need parentheses. Then I need to highlight all these. Sorry about that. Close parenthesis. Boom. Okay, and that's with 5 rectangles. So we could repeat that for all the iterations that they gave us. But now I'm going to go to 500. And let's see. If I'm going to do 500, then this needs to change to divided by 500. I'm going to have 500 subdivisions. Okay, so I'm going to have to pull that down. Okay, I'm going to get some big things. And then my length is still going to be to the fourth power. I've got scientific notation going here. And the area, if you take 1 divided by 500, you get 0.002. So I need to change that right here as well, 0.002. And I need to fill that down as well to change my formula. Okay, so now to get all the way down to 500, I'm going to highlight all of these, and I'm just going to drag this down. Actually, I probably should just highlight the last 2, just to be safe. So now I'm going to pull it down, and let's see, I'm starting at 2, so I'm going to need to go down to 502. And we have to wait, try and make it go faster. There it goes, slowly but surely. Here we go. We're halfway there. I wish I had a good joke to tell, but I don't. Come on, Excel. Okay, we're getting there. All right, so I think it's going to be 502. Is that going to give us 500? Yes, it is. Okay, so now I'm going to do my sums down here because I don't want to drag all the way up, left and right. Okay, so for my left rectangles, that's going to equal the sum from, let's see, D2 to the second to last cell here, and that's going to be D501. Okay, 0.199999. And then the right rectangles are going to be the sum from D3, that corresponds to x sub 1, all the way to D502. And that's 0.20. And I'm going to copy that real quick to help us answer the question. Let me go back here. Okay, drag that over here. So my left rectangle had a sum of 0.199 and my right rectangle had a sum of 0.20. And it looks to me like these guys are approaching the sum of 0.20. So I'm going to find it to two significant figures, and that will be 0.20. That's what it seems to me it's approaching. After all, you know, this is an overestimate and this is an underestimate. Okay, so that's how you would use technology. The next example says use graphical evidence and known area facts to find the integral from 0 to 2 of 2x plus 1. Well, I've graphed these ahead of time. The integral from 0 to 2 of 2x plus 1. Okay, so I'm going to make sure I understand that area. Let me get the right figure here, and I'll make this red, and let's just go straight up to get an approximation here. So we're talking about all of this area. Well, if you look, this is just a trapezoid. It's a trapezoid laid on its side, and the area of a trapezoid is given by 1/2 the height of the trapezoid times the sum of the two bases. Okay, so the height of this trapezoid is going to be along here. So from 0 to 2, that's going to be 2. So 1/2 of 2 times the sum of the two bases. Well, this base is equal to 1, has a length of 1, and this one goes all the way up. Looks to be 5 to me, but let's make sure. When x is 2, 2 times 2 is 4, plus 1 is 5. Okay, so that is just going to be 1/2 times 2 times 6, which is going to be equal to 6. So that means the integral from 0 to 2 of 2x plus 1 dx is equal to 6. And why is that? Because this represents the area under the curve of the function 2x plus 1 between the curve and the x-axis. And that's what we just found. One more example. I've graphed b, f of x equal to the square root of 1 minus x squared. Well, recall that the formula, or a formula, for a circle with center 0, 0 is equal to x squared plus y squared is equal to r squared. Okay, this looks circular to me, and hopefully you recognize this as a half circle. But just to show you real quick, if I solve for y, I get y squared equals r squared. Now r is the radius, and clearly the radius is 1, and 1 squared is 1. So that would be 1 minus x squared, subtracting x squared from both sides, and y would equal plus or minus the square root of 1 minus x squared. But this particular graph is only showing the top part. Y equals the positive side, the square root of 1x squared. So clearly I have a circle here centered at the origin. And if it's centered at the origin, that means that this area right here is exactly 1/4 the area of an entire circle. Oh, that is horrible down there, and you can't really see, but you can see where this could be an entire circle. Well, the formula for the area of a circle is equal to pi r squared. So for our cases here, this is just going to be equal to 1/4, since we're only talking about 1/4, since the integral is from 0 to 1, pi times the radius squared, which is 1 squared, which turns out to be pi over 4. And that is the area under the curve to the x-axis from 0 to 1. All right, that is it. Hope you enjoyed it. We will see you next time. I am out.